The AgustaWestland AW609, formerly the Bell Agusta BA609, is a twin-engined tiltrotor VTOL aircraft with a configuration similar to the Bell Boeing V-22 Osprey. It is capable of landing vertically like a helicopter while having a range and speed in excess of conventional rotorcraft. The AW609 is aimed at the civil aviation market, in particular VIP customers and offshore oil and gas operators. Development Origins and program changes The BA609 drew on experience gained from Bell's earlier experimental tiltrotor, a 1515. In 1996, Bell and Boeing had formed a partnership to develop a civil tiltrotor aircraft. However, in March 1998, it was announced that Boeing had pulled out of the project. In September 1998, it was announced that Agusta had become a partner in the development program. This led to the establishment of the Bell Agusta Aerospace Company, a joint venture between Bell Helicopter and AgustaWestland, to develop and manufacture the aircraft. The Italian government subsidized Agusta's development of a military tiltrotor, and as the AW609 has civilian aspects, the European Commission requires AgustaWestland to pay back progressive amounts per aircraft to the Italian state to avoid a distortion of competition. As of 2015, Bell continues to perform contract work on the AW609 program while considering commercial potential for the bigger V280 tiltrotor, where military production may reach larger numbers and hence reduce unit cost. The aircraft's purpose is to take off and land vertically, but fly faster than a helicopter. Over 45 different aircraft have flown providing VTOL and STOL capabilities, of which the V-22 and the Harrier, Yak-38 and F-35 jets have proceeded to production. By 2008, Bell estimated that very light jets and large offshore helicopters like the Sikorsky S-92 had reduced the potential market for tiltrotors, and low funding by both Bell and AgustaWestland caused slow flight testing. On September 21, 2009, AgustaWestland Chief Executive Giuseppe Orsi said that corporate parent Finmeccanica had authorized buying Bell Helicopter out of the program to speed it up, as Bell was dissatisfied with the commercial prospects and wanted to spend the resources on other programs. In 2013, AgustaWestland estimated a market of 700 aircraft over 20 years. By 2011, negotiations centered on the full transfer of technologies shared with the V-22, however Bell stated that no technology was shared with the V-22. At the 2011 Paris Air Show, AgustaWestland stated that it will assume full ownership of the program, redesignating the aircraft as AW609, and that Bell Helicopter will remain in the role of component design and certification. In November 2011, the exchange of ownership was completed. Following the granting of regulatory approval, media estimated that the transfer happened at little cost. Testing. On December 6, 2002, the first ground tests of the BA609 prototype began, and the first flight took place on March 6, 2003 in Arlington, Texas, flown by test pilots Roy Hopkins and Dwayne Williams. After 14 hours of helicopter mode flight testing, the prototype was moved to a ground testing rig to study the operational effects of the conversion modes. Following the completion of ground-based testing, on June 3, 2005 the prototype resumed flight testing, focusing on the expansion of its flight envelope. On July 22, 2005, the first conversion from helicopter to aeroplane mode while in flight took place. By October 2008, 365 flight hours had been logged by two prototype aircraft. The AW609 demonstrated a safe dual-engine failure in normal cruise flights on May 15, 2009. By February 2012, this had risen to 650 hours, and it was reported that 85% of the AW609's flight envelope had been explored. In 2011, AgustaWestland began construction of a third prototype. That prototype was still not fully assembled by February 2015. The company plans to conduct test flights in Italy in the summer of 2015. AgustaWestland will then disassemble it and ship it to Philadelphia, Pennsylvania, to prepare it for tests of the de-icing system in Minnesota. a fourth prototype, to be used in the development and testing of new avionics and control systems, was also underway. By November 2012, over 700 flight hours had been accumulated by the two operational prototypes. In January 2014, it was reported that in excess of 850 flying hours had been accumulated by the two prototypes. Accumulated flight data is used to further develop representative simulators, which are in turn being used to support the development program. By March 2015, the two prototype aircraft had accumulated 1,200 hours, and two more aircraft were expected to fly that year. Flight test maximums had progressed to a weight of 18,000 pounds, a speed of 293 kn, and 30,000 feet altitude. In 2015, AgustaWestland reported that the AW609 flew 1,161 kilometers from Yeovil, UK, to Milan, Italy, in 2 hours 18 minutes. By September 2015, the first AW609 prototype was reported to be near the end of his service life, while the third prototype was nearing the end of construction at the company's Vergiate facility and the fourth prototype was under construction in Philadelphia. Test pilot Paul Edwards also reported that the aircraft was not susceptible to the vortex ring state phenomena. The aircraft can slip out of the vortex on its own since both rotors will not enter the vortex ring state simultaneously. On October 30, 2015, the second of the two prototypes, which had been flying since 2006, crashed after 10 minutes of flight near the AgustaWestland facility in Vergiate in northwest Italy, killing long-time test pilots Pietro Venanzi and Herb Moran. Certification In 2002, certification of the aircraft was projected for 2007, while in 2007, certification was projected for 2011. In August 2012, the aircraft was forecast to receive FAA and European Aviation Safety Agency certification in early 2016. The company expects to achieve FAA certification in 2017. Some delays were caused by lack of funding for the FAA, others by the V-22 troubles, while AgustaWestland also spent time increasing performance and reducing cost. In 2012, the Federal Aviation Administration stated that the AW609 was to be certified in compliance with both helicopter and fixed-wing aircraft rules. Additionally, new codes were to be developed to cover the transition phase between the two modes. Of the 217 pilot training tasks, 10 are unique tiltrotor tasks. AW609 certification basis is established by FAA under the provisions of Part 21.17b, for special class aircraft along with a portion of Part 25 and 29 and new specific tiltrotor parts in a new category called powered lift. In January 2013, the FAA defined U.S. tiltrotor noise rules to comply with ICAO rules, expecting the AW609 to be available within 10 years. Noise certification will cost $588,000, which is the same as for a large helicopter. In February 2014, the AW609 was taken on its first customer demonstration flights, in both airplane and helicopter modes, and began certification flights. In early summer 2014, the AW609 performed FAA-monitored ATOR rotation tests. More than 79 power-off conversions from airplane mode to helicopter mode were made across 10 flight hours. During these tests it was stated that the minimum ATOR rotation altitude is 3,000 feet, and that the system keeps rotor RPM above the minimum 70% for stable recovery. The test pilots subsequently received the Ivan C. Kinshallow Award for their role in the tests. Further developments At the Farnborough Air Show in July 2012, AgustaWestland announced that it was to offer a higher weight variant of the AW609. This model would trade some of its vertical takeoff performance for increased payload capacity. Officials from AgustaWestland have suggested that this short takeoff and vertical landing variant may be an attractive option for search and rescue and maritime operators. According to Senior Vice President of Marketing Roberto Garavaglia, the Italian government is interested in acquiring several AW609s for coastal patrol duties. Due to an agreement with Bell, These may not feature armament. In June 2013, AgustaWestland announced that work to integrate design changes as part of a major modernization would delay the AW609 certification by up to 1 year. These design changes primarily involves aerodynamic improvements, aimed at achieving a 10% reduction in drag and a significant reduction in overall weight, boosting the AW609's performance and capabilities. In addition, separate improvement programs were underway on the aircraft's engines and avionics systems. In 2015, AgustaWestland announced the development of external fuel tanks which would permit 800 mi flights carrying 6 passengers over 3 hours. In 2015, Bristow Helicopters and AgustaWestland agreed to develop dedicated offshore oil and gas transport and search and rescue configurations for the AW609. Bristow Group signed a joint development agreement with AgustaWestland at Heli-Expo on March 3, 2015 which will allow Bristow to exclusively direct the direction of the tiltrotor for offshore missions such as oil and gas operations. The changes could extend beyond the AW609 to potentially affect the design of larger and more advanced models that AgustaWestland is planning to introduce in the early 2020s. The introduction of tiltrotors would allow for point-to-point operations, flying oil company personnel to platforms from major population centers with a greater margin of safety. Industry journalists viewed the agreement as an approval of the tiltrotor technology from the commercial industry, where previously only the military were interested. Production equals. In 2013, AgustaWestland was considering the U.S. as the final assembly point for production AW609s. Managing Director Robert LaBelle has stated that 35% of the customer market for the tiltrotor is expected to come from the U.S. market. Later reports suggest that the primary production line was to be located in Italy, with a second production line in the U.S. remaining under consideration. In 2015 AgustaWestland announced that the AW609 will be produced at its facilities in Philadelphia, the production site for the AW139, AW119KXE and AW169. 2 to 3 AW609 aircraft will be assembled there beginning in 2017, and once production matures, a second final assembly line is being considered for Italy. Design. The AW609 is a tiltrotor aircraft capable of landing where conventional fixed-wing aircraft cannot, such as heliports or very small airports, while having twice the speed and the range of any available helicopter. Outwardly, the AW609 appears to be similar to the military-orientated V-22 Osprey. However, the two aircraft share few components. Unlike the V-22, the AW609 has a pressurized cabin. As of 2013, multiple AW609 cabin configurations have been projected, including a standard 9-passenger layout, a 6 to 7-passenger VIP executive cabin, and a search and rescue model featuring a hoist basket and 4 single seats. Medevac and patrol surveillance-orientated variants has also been proposed. It has a 2-piece clamshell door that is 35 inches wide. Having about twice the horsepower of the similarly sized AgustaWestland AW169 helicopter, the AW609 is powered by a pair of Pratt & Whitney Canada .6C67A turboshaft engines, which each drive a 3-bladed proprotor. Both of the engine and proprotor pairs are mounted on a load-bearing rotatable pylon at the wing's ends, allowing the proprotors to be positioned at various angles. In helicopter mode, the proprotors can be positioned between a 75 and 95-degree angle from the horizontal, with 87 degrees being the typical selection for hovering vertically. In airplane mode, the proprotors are rotated forward and locked in position at a 0-degree angle, spinning at 84% rpm. The flight control software handles much of the complexity of the transitioning between helicopter and airplane modes. Automated systems also guide pilots to the correct tilt angle and airspeed settings. When flying in airplane mode, the majority of lift is produced by the AW609's wings, which are slightly forward-swept. The 34-foot-long wings feature flaperon control surfaces which are normally automatically controlled. In vertical flight, the flaperons drop to a 66-degree downwards angle to reduce the wing area being encountered by downwash from the rotors. A high-mounted rudderless vertical stabilizer is attached to the rear of the fuselage to stabilize flight while in aircraft mode. In the event of a single engine failure, either engine can provide power to both rotors via a driveshaft. The AW609 is also capable of a tour rotation. The AW609 will have a sink rate warning system. Avionics include a triple redundant digital fly-by-wire flight control system, a head-up display system, and full authority digital engine controls. The cockpit has been designed so that the AW609 can be flown by a single pilot and instrument flight rules conditions. Several of the aircraft's controls, such as blade pitch, are designed to resemble and function like their counterparts on conventional rotorcraft, enabling helicopter pilots to transition to the type more easily. Following AgustaWestland's full acquisition of the program, a substantial modernization of the AW609's design was initiated in 2012. These changes included new engines and the redesigning of the cockpit. As part of the design refresh, new flight management systems, Northrop Grumman inertial and GPS navigation systems, and various other avionics from Rockwell Collins were adopted. Operational history: Bell Augusta aimed the aircraft at the government and military markets. Another key market for the AW609 has been the expansion of offshore oil and gas extraction operations, which requires aircraft capable of traversing the increasing distances involved. In 2001, Bell estimated a market for 1,000 aircraft. Bell Augusta stated in 2007 that they intend for the BA609 to compete with corporate business jets and helicopters, and that the BA609 would be of interest to any operator that has a mixed fleet of fixed-wing and rotary-wing aircraft. In 2004, Lieutenant General Michael Huff, USMC Deputy Commandant for Aviation, requested that Bell conduct studies into arming the BA609, potentially to act as an escort for V-22s. However, AgustaWestland's deal with Bell for taking over the BA609 program precludes the aircraft from carrying arms. In 2001, Terry Stinson, then chairman and CEO of Bell Helicopters, declared that costs will amount to at least $10 million. In 2012, industry reporters estimated that unit cost may come to $30 million, while in 2015 some believed the price to be around $24 million. In 2004, Don Barber, then executive marketing director, stated that early orders were taken at a price of between $8 and $10 million. Since 1999, orders have been at a price to be confirmed no later than 24 months before aircraft delivery. Orders were 77 in 1999, and 70 in 2012, dependent on the final unit price. The company intends to have production facilities ready for completing orders right after FAA certification in 2017. As of March 2015, there are 60 orders for the AW609. Bristow Helicopters intends to order 10 or more. Michael Bloomberg, the U.S. billionaire businessman and politician, is near the top of the list of buyers who have put a deposit down on the AW609 tiltrotor aircraft. In February 2015, the Italian Army released a white paper documenting its vision of future procurement efforts. It included the intention to procure a force of tiltrotor aircraft for rapid troop transport and medical evacuation duties. It has been speculated in the media that the AW609 is a likely candidate for the requirement. Some of the orders are, as of 2015, on November 10, 2015, United Arab Emirates selected a search and rescue variant of the AW609, ordering 3 with an option for 3 more. Specifications. Data from the International Directory of Civil Aircraft, 2003 2004, Janes 2000, the BA609 and AW609 data sheets and others. General characteristics crew, 1 or 2, capacity, 6 to 9 passengers or 5,500 pounds payload, cabin height, 4 feet 8 in, cabin width, 4 feet 10 inches, cabin length, 13 feet 5 inches. Length, 44 feet, height, 16 feet 3 in nacelles vertical. 21 feet 10 in nacelles horizontal, wingspan, 38 feet 5 in, width with rotors, 60 feet 5 in, rotor diameter, 25 feet 10 in each, rotor area, 981.75 square feet, empty weight, 10,483 pounds, useful load, 5,500 pounds, fuel, 2,480 pounds, fuel burn, 1,000 pounds per hour, max takeoff weight, 16,800 pounds, 18,000 pounds STOL, power plant, Tua, Pratt & Whitney Canada .6C67A turboshaft, 1,940 shp each. Performance maximum speed, 275 kn. 293 kn tested, cruise speed, 260 kn, range, 715 mi. With external tanks, 1,100 mi, ceiling, 25,000 feet, 6,000 feet HOGE, rate of climb, 1,500 feet per minute, gravity load, plus 3.1, minus 1.0 g, disk loading, 15.8 pounds per square foot. See also, related development, Bell 15-3, Bell HV911 Eagle Eye, related lists, list of VTOL aircraft. References. Bibliography Venanzi, Pietro. Wells, Dan. AW609 tiltrotor flight test program overview. 2013 Flight Test Symposium. November 2013. Fort Worth, Texas. AgustaWestland. Further reading, Agree, J.R., Cecil W. Johnson, Wayner Performance, Loads and Stability of Heavy Lift Tiltrotors. AHS Vertical Lift Aircraft Design Conference. January 18 20, 2006. San Francisco, California. NASA. 20,060,013,409. External links, AgustaWestland AW609 at AgustaWestland.com, AW609 promotional video by AgustaWestland at YouTube.com, video of VIP in Rescue Interiors, interview with test pilot by AVWEB.